So it's nice to meet you all. My name is Matan, co-founder and CTO of Rapido. We've been around for almost 3 years, started the company in order to solve a very, very interesting problem in the databases world. So how many of you here are managing or living in a world of a SaaS application? Yeah. How many of you are using Postgres or MySQL on RDS? Yeah. How many are managing more than 10 DB instances? Okay, yeah, it's definitely what I was expecting to see. So in in a world of managing a fleet of databases, it is in many cases. So why do we have? Let's start. So let's start with the why. Why do we manage so many databases more than ever in the history of IT? Essentially, one of the things that happened with the world of multi-tenant application, SaaS application, is that companies had to split their underlying database either based on instance per microservice or instance per tenant. And due to that, we found ourselves managing dozens or hundreds of Postgres and MySQL instances. And we see that in many cases, like the companies who are managing a fleet of databases have to rely on SRE and operational teams to actually make that happen, make that work at scale. And in many cases, it's not easy, right? This is like the stepson of every team. Nobody wants those databases. Nobody wants to take care of them. And they are introducing various challenges, right? When I manage 50 databases or 100 databases, it's very hard to maintain uptime, right? What happens if CPU spikes, if IO spikes? What happens if I have locks on my database, right? All kind of engineering or dev related issues that could actually trigger a lot of operational issues on my databases, right? Now, when I lived in a world of 5 or 6 Oracle instances with 5 or 6 DBAs managing them with the umbrella of Oracle, it was not like very hard, right? It was great. But doing it within the SRE team, multiplying that by 500 makes it very hard to do basic stuff like how do I know what is the slowest query across my fleet of databases? How do I find which instance I've recently scaled up in order to support my load that happened due to who knows why, right? Like developers threw query on my database, it spiked to 100%. I had to increase what other weapon I have as SRE, right? Like besides increasing my underlying infrastructure. So how do I keep track of that? How do I know that issue is over and I can shrink my database back? If you think about it in RDS, you typically have to increase your database by 100%, right? So it's not like a small adding 2 CPUs here. It can actually become very expensive. You can get like backfire from FinOps and who knows. When I'm managing a fleet of databases, how can I be proactive and not reactive? I got to find different tools than the tools that I got out of the box, right? I can't look on each database as one database. I got to start thinking in matters of fleet of databases. So this is exactly the problem that we are solving here at Rapido. Developers are building queries essentially with ORM most of the time. Who knows how many queries, like how many queries in the world today are written in native SQL, like SQL queries? How many of them are written in native SQL and not ORM? So the estimations, nobody knows the real number, but the estimations are around 7 to 10%, right? Like most of the queries in the world are generated by ORM, right? And that generate various problems to people who are managing the underlying fleet of databases, right? So developers sitting there, they write Java code, Python code. Under the hood, you have Hibernate or another ORM platform that generates the query. The queries are hitting the database. And in the ops side, I am actually in charge of the performance of that. So if we have a slow query, typically the SRE is going to be in the front line. If we have SLA issue, that's not very reliable, right? Like for site reliability engineer. So we got to increase the reliability of that system with no tools, with no weapon, right? What happens when I have to increase my underlying infrastructure to support it? So it's all very hard problems to solve as an SRE when I don't have the tools. Sometimes I know the answer. I know that this is a remarkably idiotic query that is hitting my database. I know that this query is hitting my database 5,000 times without waiting for any response. I know that, but what can I do? I have to open a Jira ticket and wait for someone to do something about it. Those days are over, right? So we all need one tool that not only changes the way we consume database observability, so it's not only going to give us the ability to look across a fleet of databases, it will also give us the ability to deploy real actions to protect my database from issues, right? It got to have some no code, essentially, abilities to control what happens on my database. We believed when we built Rapido that this tool should have a full-blown observability, as I said. It should improve your database resiliency. It should essentially reduce mean time to, someone said today, MTTI. I'm used to MTTD. So mean time to detect, or mean time to detect and mean time to resolve, like as low as possible. And if with automation, we can actually make mean time to resolve the same time or very close to the same time to the time of mean time to detect, we're actually winning like from all fronts, in all fronts, right? So we want to reduce mean time to detect as close as possible to zero with automation. So when I detect that something happens, or my system or my machine detect that something happens, I want to respond immediately and solve the problem. It's not going to be for 100% of the issues, but it's going to be to a certain amount of them that will actually move the needle. And we also understood that people are covering on bad code or bad SQL queries with excessive infrastructure. So we understood that our tool must allow companies to reduce their spend on the underlying infrastructure. Okay, so let's move and see a live demo. Or you know what, before the live demo, I want to show you one of, so this is, we have the full case study in our website, so you can look it up in Rapido.io with a company called Trax. Trax is a retail AI company. They were in the AI like business 10 years ago. They have huge customers. And what they do is actually, under the hood, they manage an instance per tenant. So they don't have a lot of customers. They have 70 customers, but those customers are Coca-Cola, Mondelez, very big clients that pay a lot of money to them, right? So what happened under the hood is that they had dozens of R5 8XL. It was before Graviton, or they still couldn't move to Graviton back then. R5 8XL instances are costing what? $3,000 approximately per month. So it's expensive instances. Dozens of them reach like hundreds of thousands of dollars per month, like for the AWS bill, for the RDS bill. And look for a second on the behavior of their CPU. So the CPU was by far the most stressed resource that they had to increase their instances because. So it wasn't like database connections. It wasn't like IO. It wasn't RAM. It was CPU. So as you can see here, like before they started to use our automations, the CPU was swinging between 0 to 60. This is 60, this is 80, right? And this is 100%. So every once in a while, they hit 100%, and 100% is emergency. It's a production issue. The system is down. Not a pleasant situation to be at as an SRE, right? Everybody's yelling. And essentially, you got the guy who is in charge of those databases that has to disappoint someone, right? So it's either that I'm going to take this instance to 16XL, right? And I'm going to pay $6,000 per month, or it's going to get down every once in a while, right? So I got to choose whom am I going to disappoint. It's either going to be the FinOps team or the customer-facing team, and nobody wants to see the face of the customer-facing team when they are disappointed, right? That's a nasty situation to be at. So in the end of the day, they had to choose, and they chose not to increase the instance. Luckily, they had Rapido coming in. So after deploying a couple of very basic rules like caching and throttling, look what happened to the CPU utilization immediately on the same day. So instead of swinging between, the baseline went down from 40% approximately to 10 or 12%. Spikes were not crossing the 30%. At a certain point right here, you can see they decided to shrink the DB instance to 4XL. So instead of going to 16XL, they actually went down to 4XL. And after some time, by the way, this is not something that we encouraged, right? Like we were happy with keeping it like 8XL, but they saw the benefit, they saw the opportunity, and they shrink it. And at a certain point, they also decided to shrink it another fold to 2XL. So instead of paying 6,000, they started like to pay around, instead of paying 3,000, they started to pay around 600, right? So massive cost optimization. Multiply that by 50 instances. So it was dramatic. They saved a lot of money, like more than $1 million per year only on RDS, right? Now, let's move to a live demo and see how the magic was done, right? So this is Rapido. This is our platform. Let me real quick cancel the optimization that is being done so we can start see things happening. Can you hear me? Yeah? Okay. So this is the Rapido master dashboard. Let's kick that guy out. So this is the Rapido master dashboard. Like when you log into our system, essentially what we did is to give you a bird eye view of what's happening across your fleet of databases, right? So Rapido was not born to the world of AI. We started 3+ years ago. ChatGPT came right in the middle, right? Like right after we raised the seed. So we built a platform for essentially observability and automation. It wasn't like AI native. And if you think about it, like here, you can actually see a bird eye view of what's happening across your fleet. So what is the average time across, the average query time across my fleet of databases? So 8 seconds, every tile here, you could actually drill down and see per instance per database, right? So think about a world of people who are managing. Anyone here has instance per tenant architecture, DB instance per tenant? No one. Anyone has DB instance per microservice? Yeah, that's way more common. Okay. So think about a world of instance per tenant or instance per microservice. In many cases, I want to know what is the baseline of the CPU, or I'm sorry, of the query runtime across those instances, right? If it spikes, I want to know. Think about the maximum query. What is the longest query across my fleet of databases? I have a query of 5 minutes. I can easily drill down and I can see which query was that. Like it was a select SQL calc found rows from the parents table. It was executed 12 times. And another interesting item here is that sometime one of those 12 times, it actually ran in 1 second. So the range of the execution time of that query is anywhere between 1 second to 5 minutes, right? So it's either very, it either differs on concurrency, like when it runs multiple times, it gets slow, or that my database at certain times of the day is very busy and generate terrible results. But on any event, this is an unreliable result. Just a sec. Think about locks, right? Like across 500 databases. So here, you can easily see the databases with the highest amount of locks, right? I can drill down. I can see a flat list of all the locks. Again, using group by is very useful capability. So you can easily see that like out of, what is it? Let's cancel the group by for a sec. So out of 5,300 or 5,400, around 90%, around 5,200 are happening on one specific DB instance. If I expand that again, and I group by the locking query, by the locking entity, you can actually see that there are essentially 2 queries across my 500 databases that are generating most of the locks across my entire fleet of databases. At this point, I can go and address it with traditional tools like code and code changes, or I can use Rapido automation to go ahead and actually do something about it. We'll see in a second what can we do with that. Detecting issues from the bird eye view and drilling down and finding the root cause is something that you can do very easily with that tool, right? Now, the other area that Rapido is unique, and I don't believe that if you know any other product that does that, I would love to hear it. I didn't find any. Giving you real-time visibility to what's happening on your databases, right? Like in the context of relational database, when something bad happens, I really want to get there right now and see what is happening right now, regardless of my ability to gain notifications and alarm when I have the ability to do things in real time. Here you can see a flat list of all my MySQL and Postgres instances. And again, I can group by is like when you work with tables, like group by is very important capability. So I can see that I manage 14 MySQL instances, one Postgres instance here. I can see that one of my SQL instances is on 100% CPU. I can see that there are a lot of connections. So it has 250 connections available, and almost all of them are occupied. And there are 3 minutes query running on that database. I can drill down and I can see in real time what is happening on that specific box, right? So you can easily see that something happened here in the last few minutes. Something started to compound. And if I go and guess what, group by again, you can actually see that we have the same query running 150 times on my database, 180 times on that database, right? So this is where Rapido differs from, again, all the other tools, right? I can go and pull the trigger and kill that query right on the spot, right? Or kill that group of queries right on the spot. I can do real action to fix the problem right there. Even if I will do it, it takes few minutes, like to kill 200 queries, like on the database. So let's let it run. But one of the things that I want to do, and that's really unique, is to be proactive about it. And this is where we get into the world of automation. So in automation, we can do, this is very powerful engine, right? Sharp tools are introduced, and we can do anything from killing one query based on a trigger to build like intricate caching systems. So if I go and, for instance, look on my Scout rules, right? Look what I can do here. I can define essentially any trigger. So whenever user that named, who do we got? Daniel, I saw you. Yeah, so user named Daniel is reaching my database, right? Whenever this guy reach my database and executing a query that does select star, yeah? And I don't care what happens. This is a wild card, right? I don't care what happens after select star. So whenever Daniel is running select star on my database, I want to get notification about it, right? Notify me to Matan at Rapido.io, okay? Just let me know when this guy is doing bad things on my database. Alternatively, I can be more aggressive. I can just kill the query. I can kill his connection. Whenever he execute a query, a select star, we don't like those, like in the DBA world, we don't like the people who do select star, right? Without specify what you want, like from my database. Don't ask for everything. So it's, hey, tell me everything about this table. No, we don't want that. We want you to know exactly what you search. So I can actually execute action. I can rate limit. I can say whenever that happens, just rate limit to 1. Allow it to run 1 time in parallel. Alternatively, I can get even, and by the way, I can go and deploy that on 1 or multiple instances. So what you get here is the ability to build policies and guardrails on your database, right? I can define what users can do on my database. I can define what queries can do on my database. I can define what specific endpoints, microservices that are hitting my database, what can they do? And this is really powerful. Now, on top of that, we have the world of caching. How many of you are deploying caching engines like to your databases? Like anyone is, yeah, Redis, yeah, of course. Is there anyone who doesn't do that? Yeah. So how many ops people, how many SRE people, not necessarily ops, how many times you SRE deploy caching? Not a lot. But how many times you have that question, why the hell nobody cached that query? Why the hell nobody did that? You want to go ahead and cache the query, but you don't have access to the code, right? So look at this. Using Rapido, not only that I can go and cache a certain query, I can actually define table-based invalidation. Table-based invalidation will allow me to deploy a caching for a specific query on my database with no code changes. So that practically means that whenever that query will hit my database, Rapido will offload it to a caching layer. And not only it will be on a caching layer, Rapido will also make sure that whenever there's an update to that table, the query will update as well, will update the data. So essentially, this gives SRE or people with no access to the core code the ability to deploy caching rules on the database with no code changes, right? And if I go back to the issue that we had at the first place, so we have a query running, we have database 100% CPU, we drill down, we see the query, look at this, right? So this is where I killed the 100 queries, so it went down to 75, but my application kept throwing that query to my database again, and now we are facing, again, 200 executions of that query, right? So let's go and build an automation rule to protect our database from that query. So I copied that query name, look at that. So select SQL calc found rows. Anyone know what SQL calc found rows do? Yeah, it's a terrible compute intensive query that will essentially get your database stuck. Lazy developers could use it like instead of doing calculation in the code. And we want to make sure that whenever someone execute that type of a query, he's going to get a certain limit. It's not going to run as much as they want. First, I can go and build a rule that will do it for me. So I'm going to say whenever anyone executes a query like that, right? So this is a copy paste of the query, but I don't want to do it only on that specific query. I want to do it whenever anyone runs that function, right? I don't care what you do before or after that function. Whenever that function is coming and detected by our engine, we will allow it to run only one time in parallel, no more than that, right? And I'm going to apply it only on the instance that I saw that it happens. Let's call that SREday San Francisco. And I don't want notification. I don't even want to know about it. If you run that idiotic function on my database, you're going to pay. So I'm going to drill down now. And let's see what happens. So you see that it's gradually dropping. Let's accelerate the drop by killing that query. And within a few seconds, you will see that it dropped. It's set on 3, and it's not going to spike again. The rule will be enforced, right? So this is the kind of things you can do with Rapido. Now, on top of that, and this is something that I want to introduce today, like for the first time in history. So if you think about it, you really need that's the danger zone, yeah? You really need some database knowledge, some expertise to use that tool. Who feel that like they can use it without any databases knowledge or with minimal database knowledge? It's hard. So we're introducing Rapido Scout AI that will not only give you a prompt access to the tool, but will also give you the ability to build your own insights with natural language on top of the data that we have and we store under the hood. Okay, so if you think about it, I want to go and ask my model essentially, show me. Okay, let's make a new query, right? So show me, and it's not 100% going to work. Keep that in mind. We will try twice or 3 times until it works. Show me all, or show me the most important performance issues across my fleet of databases. Not the most important, but the most, what's the word? Urging? Yeah? Impacting? Urging. No, not urging? Yeah. Performance issues across my fleet of databases for the last 24 hours. This is a morning. I came to my chair. I start to see what's happening. I want to know what happened across my fleet of databases. Or alternatively, something happened and I don't know exactly what is that, right? So it's running there. I did run it before. Oh, in real time. Yeah, it worked. So look at that. I notice an error in the query used to detect performance issue, the error occurs because it didn't work. Okay. A percentile Windows function. Okay, let's be more specific with what we ask, like the model here, okay? So not the most urgent performance issue, but the most urgent CPU and IO spikes across my fleet of databases for the last 24 hours, right? So this is still in the making. We are optimizing that context window or whatever you want to call it all the time. It's still in the making. So the more specific you become with your request, the better results you're going to get. Okay, look at this. So we got something nice here. Critical situation summary. Yeah, April 11th. This is today. Fleet-wide issues affecting multiple database instances, right? Extreme CPU utilization with concurrent high I/O. So all instances showing CPU utilization of 100%, yet this is exactly what happens, right? Like in this environment. So this environment was built like for that scenario. So you can see that we got a lot of databases that are suffering from high CPU utilization. So it says it's not all, but it's almost all databases are suffering from high critical CPU utilization. The most severe one is this one with 100%. Same goes for IOPS. I don't want to see my AWS bill next month. It's not going to be nice. Blah, blah, blah. Very interesting. Okay, now by the way, we actually got the underlying data here. So you can see that the DB instance, the CPU utilization, and the max IO, right? And again, it was all built by natural language. Now, let's be more, what's the word? Let's be rude and try to extract more out of that, right? So now, please show me which queries contributed to these CPU spikes. What do you think? Is that going to work? So we go from a bird's eye view across 500 databases. We saw a bunch of CPU spikes. Now let's see what really generated these spikes. I never ran that query. Okay. While it's running, here you can see that like our previous problem was solved, right? So CPU amount of queries went down to 12, 13, instead of 200. So that's nice. And yeah, this guy don't want to respond. That's the price. That's the toll you pay when you make a live demo. That's fair. Guys, any questions? Any thought? I believe that summarized a certain amount of what I wanted to show. I can stand here and speak all day, but
how do you test this AI? How do you test that the things that are coming back are actually what you asked?
So first, like you got the underlying, you always got like, sorry, like the request here failed. Let's try to re-execute it, not ignoring your question, Riley. Let's try again. You got to try it out, right? Like the underlying data is available there. And one of the things that we're going to do, essentially what it does behind the scenes is just to generate a SQL query on top of the Rapido database, right? The underlying Rapido database. That's the only data source that we're using. So there are no like what you saw with Newbird. They are connecting to a bunch of data sources. Oh yeah, we got the result. No, it's not work. We're connecting to one data source. So it's quite easy to just take the SQL that it generates. We're not exposing it here, but we're going to expose it like the SQL itself. And you can just take the SQL and execute it like against Rapido. If you see here, we got like a built-in engine called execute query, right? So execute query, I'll show it in this environment. Execute query is essentially a SQL client, if you want, that can execute any SQL that you want against all your DB instances, right? So if I'm going to go and let's remove my Postgres, where is that? That's my Postgres DB. So if I'm going to go and do show me all databases, so I just execute the command show databases on all the instances because we have a connection open to these databases. So it executes that and then you get like the result. And we also use that tool to talk to the underlying Rapido database. So essentially any prompt that you insert here generates a SQL query, and that SQL query is ran against our database. I think that the biggest gap that we cover here is for people who are not SQL expert, then they want to interact with the data, and they can just use natural language for that and do like very smart and beautiful things, right? Without how many people like have how many people have ideas, right, of what can I extract from that data, but they don't have the SQL capability to do it. So this is for these guys, which is most of us. Gentlemen?
How are you getting between you and the database? Or is it like a library in the application? Is it like a middleware thing where you're acting as a proxy? Is it like, what's it doing?
So we have multiple models. In the end of the day, this is the architecture, right? So your application, you have your application that interacts with your database or databases. We are just another SQL client that connects to your databases, and we aggregate data about the queries that are running. On top of that, we have a proxy model that can actually do the caching and some of the capabilities, query rewrite in transit. So we got that as well. Yeah. Sure. Any other questions? Yeah.
What do you do about my favorite topic, connection management?
Connection management. That's a brilliant question. So how many of you have ever had connection shortage on connections to your database? Yeah, that happens, right? So one of the things that we do with no proxy, by the way, is the ability to control database connections, right? You could actually define a rule that says that whenever connection utilization is hitting a certain threshold, like in percents, say 85%, and the connection idle time, essentially timeout, right, is reaching, I don't know, 60 seconds, you can start killing idle connections, right? So we have clients that use Rapido for that, because is there anyone here who have ever purchased a big DB instance just because it allows you to get more connections? So there are people in that position. You guys are in good position, and we were able to help them to save money only with that, only with the ability to kill idle connections. Developers are not closing connections properly. You want to make sure that your data, you need to protect your database. Doesn't matter what they do, and you cannot wait for them. So killing idle connection is very classic solution that get things run better. Does that answer your question? Any question there? No? Okay.